All right, let's go. Okay, back to it. Oh, it's too hard. All right, let's go. Music is too crazy. Why is this thing making so much noise? Okay. Oh. Okay. Yeah. I don't know why it's just underneath the threshold for the noise gate. Damn. Just a funny sound. Alright, what have we done? Initializing reference to const. Oh, okay, gotcha. Alright. Fucking cuticles, man. Alright. So we could have something like sure. Bro, why is the chair fucking squeaking? Okay, now it's good. Never mind. Yeah, so we can output not debug only. We can output my name, or we could try and change it. And then try and, oh, actually, yeah, I mean, I don't have a way of editing a standard string, but, right? I don't think I do. Yeah, I can't edit, like, the elements in it if it's an array. But I can just replace it. So if we instead, I wanted to change it to just be name2, well, I can't do it because this reference is const. If this wasn't a const reference, then I could do it. So that whole little bit of const carried a lot of weight here because now, oops. Like right now, name is Ethan, but we have a reference that's bound to it. Ethan is a modifiable L value, specifically a standard string. And then I have another name, Jack, and I'm replacing the name with Jack through the name reference binding. And then I'm outputting and showing that, hey, the name changed. But if we make the reference const, then it's like a view only reference basically. So we can sure that we can see that the name is Ethan, but we can't actually change the name. So cool. So we can make an L value reference to a constant value, an L value constant, or an L value reference to a const. Instead, bind to a modifiable value. It's basically read only. Does it say read only? Damn, I wish it did. That would have been a good way of saying it. Bombs? What am I seeing? Okay. Is it just in general? Or is it? It is. No, it's not. Okay, the pillow has nothing to do with it. Cool, I was just making sure. I didn't know if the pillow was making the force come through like a different angle or something, so it was using a non-lubricated part. Okay. References to const can bind to modifiable values. Yep. The referent is basically being treated as if it's const by the reference. So we can't we can read it, but we can't change it. So we have an integer reference, but it's const reference, so we can't change the referent through the reference. We can view the referent, sure, but we can't change it. But we can change the referent, just not through the reference. We bind it to the modifiable value, sure, we can access it, yep, but we cannot change it through ref, yep, exactly. But we can still manipulate x. So like, could we have a reference to, I guess so, right? If we can have a reference to a standard string, surely we can have a reference to a Mersenne twister. And we can change the Mersenne twister so that it's seeded differently, maybe if the values are wonky. Like we have like an algorithm that runs random numbers, but if we want two things to be sufficiently distinct, so like maybe there's a decision-making system for friendly NPCs, and then there are for one type of enemy, and then there's a decision-making system for another type of enemy. Well, if it turns out that the return values of a Mersenne twister are too similar to each other and not random enough for a given seed, maybe I use the return values of the Mersenne twister for one enemy, for one seed, but then I change the Mersenne twister, the same one, and then use those references to const references to the Mersenne twister's value for the other, something like that. So we could use the same object, and I could change it, sure, but not through the reference. Yeah, so favorite L value references to const, meaning const references over non-const references, unless we need to actually modify it through the reference. If we just need to view it through the reference, cool. And then later we'll get the passing via reference instead of by value. Initializing an L value reference to const with an R value. Oh, so references to const can bind to R values. But if the R values are temporary, I wonder how that works. Does that then make the L value reference an object? Because, I don't know, it seems like if the R value is temporary, yeah, I'm not sure, let's see why. L value references to const can bind to R values. So we have a constant reference for 5, and it's okay. When this happens, a temporary object is created and initialized, and a reference is bound to that temporary object. Yeah, but I don't know why I would want to do that, though. Because if I did that, I mean, at another point in time, the reference might not be still using 5. If that piece of memory gets changed, though. Okay. Initializing an L value reference to const with a value of a different type. So are we still, is it still as picky? Will it still not be happy? Alright, let's see. L value references to const can bind to values of a different type as long as they can be implicitly converted. So, and that's because the value would be converted. It's almost like an R value, right? Isn't it the same thing, kind of? So we could do an L value reference to const for a double, an L value double reference, or a const double reference, and we initialize it with 5, an R value, a temporary value. We can then output it, and it prints 5. But I could also have, so that's one case where we're saying We're storing it as a double, and the only reason it doesn't print 5.0 is because of character output. It kills trailing zeros. But we're using an integer to initialize a const double reference, or we can use a character to initialize a const int reference to print it as an integer. In case 1, yep, there's a temporary object, sure, and it's bound to that temporary double object. My question though is if the referent, if that object changes, it seems like either the reference has to become an object to store the information, or it's subject to changes of that temporary object, wherever that is. Okay. In both cases, the type of the reference and the type of a temporary is a match. Hold on. This is because 5 is converted to the type of the reference. So the value that we are initializing the reference with is converted to the type of the reference, or the type of the referent that the reference is referencing or bound to. So we have a character, and the character literal is converted into an integer. So we're creating a temporary integer object, which R2, this constant reference, is bound to. Compiler basically takes that value, creates a temporary object that matches the reference type, and then binds to that. Yep. Well, yeah, because the character is converted to an int. We create a temporary int, so therefore we're printing an int, not a character. Yep. Pass by const L value reference. Okay. Normally assume that the reference is identical to the object it's bound to. Well, yeah, like if I make a const int64t reference and I initialize it with 10, 10 is a regular int. So 10 is converted to a, I mean, you could say either way. 10 is converted, but we're creating a temporary int64t, the type of the referent, the type of data the reference is bound to, or will bind to, and then it will bind to that temporary object. So 10 is basically converted to the int64, which is then what the reference is binding to. And in that case, that's a temporary from the conversion of the object. Oh, so like if we have 5 though, well, so I'm curious about that temporary object then. What happens to the temporary object? Does the reference get whack? Because if the temporary object changes, then the reference will. But yeah, so if we initialize a const reference with one type of data, but in order to actually initialize the reference, that type of data is converted to another type in another place, and the initial data isn't changed, then if we change the initial data, yeah, the reference will not reflect that. Makes sense. We would have to change the temporary object in that case to reflect it. Okay, so we have short bomb. There's one bomb. But then there's a const integer reference, the bombs that you have, and so a short, is used to initialize a temporary int object, and then this const reference is bound to that temporary object, 1. But then we decrement bombs, so bombs, that initial object, is 1. We can decrement it to get 0. But you still have 1 bomb. So the point is there's 1 bomb. There's a reference to the converted bomb, and then we can lose that bomb, so it's 0, but the reference still shows that there's a bomb. Yep. Compiler will convert bombs to an int, meaning it creates a temporary object that's initialized with bombs. Yep. U is bound to the temporary object, not bombs. So then we decrement bombs, and then, yep, you still have a bomb. It's because of the different data types there. Oh! A const reference bound to a temporary object extends the lifetime of the temporary object to what? However long the const reference lasts? Because they're normally destroyed. Because normally I would think, okay, like in that case, we have u, a constant reference, and it's being, well, not even in that case, but, or yeah, you know what, sure, in that case, we get a temporary object created from the conversion, and then u is bound to that. Well, sure, in that instance, if it's used like right then, maybe we're okay. But if that temporary object changes at all, like it's created in memory, used, and then gone, excuse me, meaning like its scope is only the expression it's used in, then it's gone because it's created there and it's destroyed there, then, well, we're referring to something. So if we use it instantly, okay, like that would only make sense if we're initializing the reference at the same time as we're using it, or we're, yeah, something. But then, immediately after, it could be changed. The temporary object is destroyed, it's gone. The value at where it was in memory could be changed to anything else, and you'd think it would be like undefined behavior. But instead, yes, exactly, we would get a dangling reference, just like if we had a reference to a non-temporary object, but then the temporary object gets destroyed, or sorry, to a non-temporary object, but then that non-temporary object gets destroyed. So we have int x within some sort of scope, or within global scope, or let's say how would this even work? Or like in a function, we create integer x, and then we create a reference to it, and then we pass that reference, we return that reference. Well, the object is destroyed, but then we pass the reference. I mean, the reference would probably be destroyed too, but if we looked at where it was in memory, well, we'd get some dangling action because we don't know what would be there. Yeah, if we use that to reference the temporary value 5, temporary object to hold 5, if it was destroyed, then reference would be pointed to, or would be referring to who the fuck knows what. When a const value is that makes sense. So u in that case, which is a temporary, well, u is a const int reference to, bound to, temporary integer object created when converting the short bombs to an integer, because when we try and bind the const int reference to a short L value, well, that value has to be converted, so we get a temporary object. So if we change bombs, the reference doesn't change because it's bound to that temporary object. Well, instead of that temporary object being destroyed instantly, it's now tied to the duration of the const reference. Gotcha. So normally this temporary object for 5 is destroyed at the end of this. It actually still exists, and then it's destroyed at the end of scope. Okay, doker. Thus, because the temporary object hasn't been killed yet, we can safely print ref, which refers to the temporary object. It's not dangling. Once they're both out of scope, then boom. Rather, once the ref goes out of scope, so does the temporary, because they match. L value references can only bind to modifiable L values, but L value references to const can bind to both non-modifiable and modifiable objects, and L value references to const will prolong the lifetime of a temporary object, should it be bound to one, until the L value reference to const is destroyed. So not only can it bind to modifiable and non-modifiable, it can also bind to temporary objects, R values. It's directly bound to a temporary, not returned temporaries. Meaning, if I had an L value, let's find out. the thinking here is that if we have an L value reference to const bound to the return value of a function, sure, the return value of a function is a temporary object, but it isn't literally bound to that value. That value isn't explicitly written there in code. It's instead only returned. It's not being bound to value 5 that we've typed in. It's bound to the return value of whatever. So I'm going to do something like that, and we'll see what happens. Why am I doing that? Excuse me. This is okay, but well, this is a return value temporary, and it's different than I'm not using ref1. Yep. I'm curious where this is created in memory, so I'm going to call it again and then see what happens to the 5 and 5. Okay, so far I don't have an example where this lifetime is failing. Temporary is returned from a function, i.e. it's not directly bound. It's not eligible. So if we're returning from a function, we're returning by address maybe to the value where that value was created or where it was put. So if we return 5, we're saying that 5 is somewhere, look there. That's the return value. But if we're returning by reference, it's actually returning the reference of that thing. So if we say a const int reference is initialized with 5, that temporary 5 object is what we're referring to. Extend its lifetime. But if we're instead, we have an object that we're looking at. But if we instead say that, hey, there's a value at a location in memory, an address, look there, and then have your const int reference, look there, then it might be dangling. For class type R values, finding a reference to a member. A class type R value? I don't know what that means. Why does it allow to bind to an R value? Okay. A const expression L value reference. Only be bound to objects with static duration? Really? const expression reference cannot bind to a non-static local variable, meaning we can't even have a const expression int doing it. The address of local variables is not known until the function they're defined within is called. Meaning that we don't actually know where x is until main is called. So it doesn't exist yet, seems like. So what if we had oh, it has to be a const expression constant reference. So it's a reference to a constant. This is the type of thing it's referencing. And this is the type. This is a const expression reference. Oh, gotcha. Oops, it needs to be made static. So it's not evaluating to a const unless it's static. Because it needs to look at the address of the variable so it can change what's there, and it doesn't know it. It only knows where it's going to create static ones, not runtime ones. Okay. Passing by reference now. Shit, wait, I'm actually getting significantly more work done on the weekend than the weekday, right? Sure, it's 15 hours during the week, but I'm getting Right? And I'm only doing 6 on Saturday and Sunday. But I'm doing the same amount of testing on Saturday and Sunday as a regular day. But I'm doing 3 times the amount of the new knowledge. So like on today, Saturday, I do 4.5 hours of study of learning new shit. That's like 3 entire regular days of getting new knowledge in the brain, and then I lock all of it in at once at the end of a test. So we have L value references, i.e., references to modifiable values, or rather, references to modifiable values. That way we can change the values through the reference. But then we have references to const, references to non-modifiable values, which can still be references to modifiable values, but we can't change it through the reference. Seems like, well, we want to give it somewhere so that something else can access it instead of having to pass it and then do some expensive shit. So maybe it's like a shortcut. So it's like, hey, instead of me drawing a picture of where the sniper is on the hill that you need to shoot, and then me showing you the picture, and then you looking, and then finding the guy, how about I just fucking point to him, shoot him, boom! And then that's it. It's a lot faster and cheaper, at least in that case. Like maybe there's a piece of memory that we need to look at and update a shade or something. It's stored somewhere in one spot, and that's created somewhere here. But then I have another function that needs to go and make all those changes. Well, the function, am I gonna pass the fucking shit to the function, and then the function's gonna assign the value to the piece, but by passing it, and then that thing assigns it? Nah, dude, the function's gonna do it all. So the function needs to actually reference it. I.e., we have integer x2, and we print value x, okay? And we're calling print value. We're copying the value of integer x into this other object, integer y. We're passing the value, so x is not changed, and then we're outputting y, that other piece of information, not x. And then y is destroyed, and then boom. And we're copying it. Yeah. Yep. Okay, that makes sense. So like if we have a standard string or something, it seems like standard string view might be similar then here. Maybe it's a better way or just a more I don't know, more accessible. I'm not really sure. Seems like a standard string view is just a const, an L value reference to const version. Yep. Yep, standard string action, here it comes. Yeah, I mean it's like to put gas in my car, I make a copy of the whole fucking car and its information. And then I use that car to go and get gas. And then I bring it back and assign that gas to my car. So I created a whole car just to get gas instead of just putting gas in my car and using my own car. Alright, let me make sure I'm not actually playing the music. Oh, thank God, it scared me. I saw my voice moving. I thought it was the music. Let me get that other song too. No, no, no. Okay. It was about a kid growing up. Nice. Sheba? Makes sense. Yeah, like passing the standard string. So we have a standard string we've created, initialized it. The information, it seems like probably converted from a C-style string. I'm not sure exactly how that would work. I don't know if it's copying all that information from separate L values or how that would go. Or if it's just from one L value that's an array and it copies the bits by bit. And then, or the information bit by bit, I mean, not literally bits. And then print value, we take X, we take that information, the standard string, and copy it into a newly created standard string. We then print that and then destroy it. Copied this into parameter Y, expensive, and then done that. Yep. Just gonna kill him. I can't go any further because then I'm gonna get copyrighted again. Just a little bit. Cool. It's expensive. While this program behaves how we expect, it's inefficient. Okay. It's a standard string. It's a class, not a fundamental data type, which would be cheap. It's expensive instead. Every time. Yep. Okay. One way to avoid is to pass by reference. Declare a function parameter as a reference type or a const reference type, so we can't change the actual referent than the normal type. And then when we call it, the reference parameter is bound. Well, hold on. Yeah, the reference parameter is bound to the argument. And instead of copying it, the reference just looks at it. So instead we say, yeah, I mean, I'm guessing without looking at the code. Oh, it's compilation that says it, not runtime. But if we just made this a standard string, compilation time doesn't change, but probably changes in the actual runtime. Yeah, binding is probably a lot cheaper than copying. Yep. Yeah, that way we have binding instead of copying. Is always inexpensive. Okay. Yeah, it's accessing where standard string actually is in memory. I got pee. Should have taken my glasses off first. Do the 4 one arms real quick. Just negatives. Okay. Excuse me. cheap, expensive. We're copying the standard string from wherever it is to here. But if we instead just go boop, easy peasy, we get a reference to the thing. But we probably want to make this guy const. That way we don't change the actual value unless we want to. Probably don't though, because that's kind of like having a global variable where it's not const and anything that uses it can change it. Basically just a better way of passing the information. Like if you had if the end goal was to get me to Florida from here, it's better for me to just hop on a fucking bus or hop on a plane and fly to Florida instead of making an entire copy of myself just to fly him to Florida to do whatever and then destroy him. You know how expensive it is to make a copy of me? I'm a class, yo. Makes sense. Okay. Cool. Well, yeah, because it's going to get the address of the value that it has, but then, and it seems like we can just do and, excuse me, to get the address of something, but then we can get the address of the reference. So this is X. We're passing X, right? Or are we doing 2? Oh, okay. So we're copying X, but then we're actually passing X itself. X, this guy refers to X itself. This guy refers to a copy of X. Where is val located? Where's the copy located? Where is X actually located? And it turns out oh, Jesus Christ. Can I fucking read? DE4 versus 0. This guy is located later in memory. Different places. Oh, and it's probably because this takes up 0, 1, 2, and 3 as an integer, and then this guy starts at 4. Because this function probably has a specific spot in memory that it wants to create parameters at. So it creates 1, and it takes up this much space, so the next one comes after. These addresses make sense? Following demonstrates that a value parameter is a separate object from the argument itself. Makes sense because it's literally a copy. While a reference parameter is treated as if it were the argument, because if you change it, it actually does change the argument. The address of X is and X. Okay. And it doesn't tell us the address of the reference because references aren't objects. They're not required to be anywhere in memory. This is just saying that, hey, at runtime, print wherever the fuck the thing this is bound to is. Since they have separate memory addresses, in order for the value parameter to get the same value as the argument value has to be copied over it. Yeah, makes sense. But if we take the address of the reference parameter, we get the same address. The reference parameter is treated as if it's the same one. And pass by reference allows us to change the value of an argument. Yeah, I mean, I've already done that a bunch. So if we do this, we say, hey, X is 5, the value is 5. Add 1, copies 5 into Y, Y is 5, increment Y, and it is now 6. Output X, it's still 5. Because at no point did we actually change X. Sure, we could have done x is add 1x, but we didn't. We just called this function and it didn't change it. It only modified the copy. But instead, if we change this to a reference y and we pass it x, then it will actually be incrementing the reference of x, which will modify x itself through the reference. Why did I start this music? Oh, because I was peeing. Thought I saw piano. It's a big fun. This isn't real though, huh? What? Bro, what in the fuck is this? This doesn't even sound like Japanese. It sounds like Chinese or something. That's the key right there, baby. 5, add 1, x, references the referent. Not const, so it's changeable. Increments the reference, changes the referent. Now it's 6. Yeah, so we could do... Oh, it's kind of a cool example. And these should be objects, a different kind of object, a class object, but it's fine. Actually, we want to change it. So, or really, I didn't need to do all that. Or maybe this isn't exactly what I was thinking. This should be fuck. I can't change the reference. Well, I mean, if I wanted to do this in a function, I could, instead of having to manually do this here, I could say, hey, there's an enemy called an orc. There's an enemy called a goblin. What is the enemy the player is targeting? Okay, well, it's by default orc. The character said orc at first. And then, or we could say, it's blank at first. Nothing. So there's nothing. And then we can update the target to be this, and then output current target, and I could put print current target and it would just do this, but whatever, it's fine for now. Target. Oh, well, I should have actually just done this, and then update target, oops, target, orc, cool, oops, yes. So we say there's no target at first. Okay, there's no target. Player doesn't have a target. Oh, okay, we're gonna update target to get the value, to be assigned the value of whatever else we're passing it. So we're passing it two references. So at first, we don't have a target, and then we update. You look like in a Souls-like game. You press your button to change the target, and then that little white dot goes on to whatever you're looking at. Oh, now our target's the goblin. Oh, we switched over to orc now. I was thinking that if it would be cool if I could have a reference here and then have a function to change it. That way the target is referencing it, but it's fine. Doesn't matter. Oh, I guess that would be a pointer, though. That would be cool, because then I could just update the pointer to point to whatever. So this would be a pointer. I think that would be like that, but I don't know how that would work, so it's fine. I'll leave that for now. Pass by hold on, I'm not looking at that yet. In this example, it has 5, add 1 is called, reference parameter wise bound to the argument, which exists in memory and is in main. And then when we add 1, we're actually incrementing that argument itself wherever it is in memory. It's actually incrementing x, yes. Yep, so. Oh, here we go. Passing values by reference to non-const allows us to actually change it. Oh, meaning, well, yeah, because we can't set, well, duh. We can't pass by reference to an L value reference, but pass it a fucking non-modifiable argument, because then that reference would be bound to a non-modifiable argument. So we could modify the non-modifiable argument through the reference. We would have to use a const one to do a const. So like if we wanted to, I don't know, get some, just pass the class, pass orc. Excuse me, and orc wasn't changeable. Orc is just orc. Then, well, yeah, in that case we can do it. If this was a const and const, oh, I was already doing this here, so say this is fine, and we can call update target, updating target, not, it's modifiable, but then we can pass it a non-modifiable orc. Okay, but if this guy wasn't const, no bueno, because we have dropped the const qualifier and it thinks that, oh shit, you're gonna be changing orc. Oh no. Can't convert argument 2 from a const standard string to a standard string. right? Functions that modify the arguments. Yep. If we have a function that determines whether a monster has attacked the player, or, well, hold on. If a function that determines whether the monster has attacked the player. If so, the monster should attack the player. Yeah, instead of having to copy the player's health to the function, change the health. It's the exact example I made in this very video earlier. We have to copy the player's current health, 100. Subtract the damage from the health. Now it's 100 minus 10, 90. Or 100 minus 60. It's a dangerous monster. It's a fucking monster. Now the player's health is 40. Now assign that to be back to the player's health. How about we just pass the health as a reference? The health is modifiable, note. And then we just subtract 40 from the reference to the player's health. Boom, changing the player's health. Or, better yet, just pass the player itself and then in the player modify it. Instead of having to copy the whole player or having to copy a piece of the player. If I pass the player object by reference, the function can directly modify the health. But if I do it by value, yeah, I can only modify the health of a copy, and then I have to manually assign that. So it's not as helpful. I mean, it's still useful because I can still assign it. I could say assign the health to be the return value of a function, and I pass it the health, and I pass it the damage, or the damage is already in there. And then boom. Pass by reference can only accept modifiable L value. Yeah, we've already talked about this. Because if we pass in a non-modifiable argument, then, well, it's not true. Pass by reference. We can pass it by reference, but it has to be a const reference. This is a pass by non-const reference, can only accept modifiable ones. Because a reference to a non-const value, so a non-const reference, can only bind to modifiable ones to prevent modifying const values or variables. We can only do this with modifiable L values, which means this significantly limits the usefulness of a pass by reference to non-const, because we cannot pass const variables or literals. Well, I mean, it doesn't limit it that much. We should only be able to modify modifiable shit. But we can pass const shit, and we're cool. Bet you this chapter's gonna be longer. I'm not done yet. No, it's actually shorter. But I guess it makes sense, because we've already covered the main points of passing by reference at all, in general. But yeah, we can't modify we can't modify const variables or const expression variables, nor can we modify literals, temporary objects, because we can't reference them. X is 5, X is modifiable, so we can call print value with X, and it actually looks at X and prints X. But if we do constant Z5, we can't pass that, because then it thinks that, hey, you might try and modify that motherfucker. No, sir. But then if we do 5, that's an R value, and R values aren't referenceable, or we don't know where R values are in memory, so we can't change them, I think. Oh, I knew it was longer. That was my initial guess. Unlike a reference to a non-const, which can only bind to modifiable values, a reference to a const can bind to modifiable and non-modifiable and R values to extend their lifetime. Gotcha. So if it's const, then we know, hey, you can do const because you're not changing them. You can do non-const, not modifiable arguments too, because you're not changing them. It's fine. But you can also do literals, R values, and we will extend the lifetime because reasons. I guess that's just how C++ is made. int x modifiable, we can print it. We can't change x here, but we can print it. Constant z, we're not changing it, so we're cool too still. We're using our const reference, not a non-const reference, and then we can print it. And then we can also do 5 itself. 5 is an R value. We have a constant reference here. Boom, we're good. And then we can print. Well, yeah, because if we're just trying to get the value there, we're cool. If we're trying to manipulate something, well, we don't want to manipulate non-const shit. Or, sorry, we don't want to manipulate const shit, non-modifiable shit. So it's good. We just do what we need to do. True. Oh, yeah. If the reference is constant, we can't change the fucking value that we are referring to, the referent. We can't change the referent through the reference, so we don't do it. Even if the reference is modifiable. Makes sense? So we're using it to do cheap passing, so that we don't have to copy a bunch of shit. Favor passing by const reference over non-const reference unless we specifically need to change it. Yeah, makes sense. How we can understand the motivation for allowing const L value references to bind to R values. Without the capability, there'd be no way to pass literals or other R values to functions that use pass by reference. I mean, we could still just call the function, pass in the literal, which gets copied in there. So if we're doing expensive literals, then yeah, then we would have to copy an expensive literal wherever the fuck it exists in. So yeah, I could agree. If you want to access expensive literals, yeah. Passing arguments of a different type to a const I value reference parameter. Yeah, isn't this the case where we just a temporary object of the type of the const of the L value const reference or of the const L value reference, our L value reference to const is created. It's initialized with the unconverted data. And then the type is itself, or the type matches the references type, or the references referent type, temporary object action. Yeah, just needs to be convertible. Temporary object, yep, exactly, cool. Is a value parameter or a reference? Yeah, because otherwise, if we had to pass it explicitly, like if I had I had the character's health, and I have a function, or I'm making two different functions. Let's say, or I'm passing the character as an object, or sure, I guess I'm just passing the character's health, and I pass it as an integer, but the thing affecting the character health initializes a double. So we're using an int to initialize a double. Well, the int gets converted into a double so that it can get assigned to the double parameter. Similarly, if we pass by reference that integer, to a const, then it gets converted to the type of the const reference, or the L value reference to const. And then that reference is bound to the temporary object. Yeah, so we can do print value or print ref. And we can do 5 or we can do 5. And in the first case, 5 is converted to a double. We output it, 5. And then in the second, 5 is converted to... So 5 is a temporary object somewhere, and then it will get destroyed after this. But during this, it will be converted to a double value 5 for a temporary object that was just created, which will live as long as that double reference does, which will still probably be destroyed at the end of this expression. Converted the temporary double. Converted the temporary double. Instead of being copied as value, the value being copied, double, or the const double reference D is actually bound to 5, or that temporary object. But if we pass by reference, and then it creates another version, the whole point of us passing by reference was to get around the passing by value. So in this case, if we pass 5, 5 gets copied to a newly created temporary object. But if we pass 5 as a reference, or rather, I guess we receive it as a reference, because it seems like it's not how you're calling it, it's actually how you're receiving it. If the parameter is receiving it, that's a fundamental type and not a reference, it will be copying the value over to it. But if it's a reference that's receiving it, then it will be binding to wherever the value is. But in this case, it's actually binding to a newly created temporary object, meaning that in both cases, there's a newly created temporary object. And if we were trying to pass by reference to avoid some expense, like we were passing a standard string, but let's pretend that we weren't receiving it as a standard string, we were receiving it as some other string. Well, then we have something then the standard string value would be converted to something else, so probably copied and converted, which is expensive, undoing what we wanted to do, and then the new string reference would be bound to that. So we would have the same issue. So for references, we might not want there to be conversion. There it is. Yeah. We use pass by reference to avoid making a copy. So if there's a conversion, it'll probably make a copy, which is not what we want. It's the whole point of what we were doing. I do this effort to make this a reference, and I make sure my code is safe and whatnot, and everything's constant good, just to not get the same, or just to get the same outcome, the same expensive outcome. With pass by reference, make sure the type of the argument matches the type of the reference. Otherwise, we get some fucking copying going on and conversions. Not what we want, yo. On. Let me trim these nose hairs, dude. This is just fucking crazy. Better. Holy shit. Okay. Yeah, don't mix them, bucko. Don't fuck it up like that. Use pass by reference when the types match. Okay. Mixing pass by value and pass by reference. A function with multiple parameters can determine, well, yeah, it makes sense. I mean, for example, like, what would be a case? I want to pass the standard string, but I want to copy something. Yeah, maybe that makes sense. So, like, or, so there's a spell called duplicate, and cool. And we need a standard string, standard string enemy. But then, int num copies. But then, we need a standard string reference. And, I mean, we may as well make it const, so we don't fuck it up. And then we will just say, what are we gonna do? We're passing the enemy cheap, and then we're doing this, and then, whatever, fuck it. It's just gonna output some shit. That's all it'll do. Okay. I mean, do we want a standard string to be const or not? Maybe. Makes sense that a wizard's doing the copying, and then we just call. And maybe wizard would be an object, wizard name would be a property or like some piece of information in the object. So standard string would be a piece, and then it has a member function for duplicate spell, and we just call this within it. Excuse me. And I don't know anything about member functions, so I don't know if there's a more convenient way of passing this information to it, or if it already has it. I don't know. I mean, probably it might. Just like in a namespace, a function in the namespace has access to the information in the namespace. So if there's a standard string in a namespace and then there's this function has access to the standard string. It already sees it. So for a class, maybe we don't need to pass the name, a fucking property of wizard, into a function that already sees it. So it copied itself, so now there are 5 copies of wizard. We are cheaply passing wizard via reference to duplicate spell. And then we are just doing regular passing by value for the number of copies, because we don't really care. Oops, this should say, oh, well, oh, I didn't put copies now exist. And if I wanted, we could do an int reference, but it would need to be a const int reference in order to receive this guy, because it's an R value. Cool. That read right? Makes sense. Yeah. So here we go. We have a function that has some pass by value action, a pass by reference, but for something that's modifiable, and then a pass by reference, but it's a constant reference, so we can't modify whatever it is we're getting. And we could do an R value, we could do a modifiable value, a modifiable L value, or a non-modifiable L value. X is 5, standard string S is hello world, and we can call foo with a modifiable L value that we're passing, passing the value of. And then we're cheaply doing, oh wait, hold on. And then we are, oh wait, what's B? Hold on. Oh, so we're passing by value the literal 5, passing by value the integer 5 from our L value. So R value, modifiable R value, modifiable L value, and then non-modifiable L value, a const reference. Okay. Cool. Okay,